Okay, let's get started with talking about how to balance chemical equations. Now this can be very challenging unless you break it down into small steps, which can make it much easier. So there's some general guidelines to keep in mind as we begin this process. The first thing we need to keep our eye on are that there are 4 different types of chemical reactions that you need to be aware of. And there are actually more than this, but these are the 4 basic kinds. First we have synthesis, where you essentially have 2 different things that come together. Then we have decomposition, which is the exact opposite. Again, you will have one large molecule or compound that will break apart into 2 smaller portions. Single displacement, which is going to involve an ionic bond, and what will occur there is a metal will take the place of a less reactive metal in an ionic bond. And then the last is double displacement, where 2 metals in 2 separate ionic bonds will actually switch positions. So with a single displacement, I like to say the reason we call it single is because it results in 1 new compound, whereas with a double it results in 2 new chemical compounds. And again, those last 2 are going to be ionic bonds. So the guidelines that I want you to keep in place as you solve these, let me kind of adjust my camera a little bit. First of all, when you're balancing, if you have a solo atom, an atom by itself, always save that for last. Make sure that you're consistently checking the quantities of each atom on both sides of the equation. And when you balance your changing coefficients, you are never allowed to touch or manipulate the subscripts. You have to leave those alone, and we'll talk about what that is in just a moment. And finally, make sure that you're using your math skills when you do this. A lot of the skills that you need to do this, you've already learned. You just don't know it yet. So when you talk about least common multiple, I believe you guys started learning that back in elementary school. You started to also balance equations. You know, you had to think kind of backwards. Like if you knew that n plus 3 equals 5, you had to work backwards and figure out that n, or x, was 2. So it's the same concept as what you did when you were much younger and what you have been doing this year in math. So you're going to use those same skills here with this. So let's look at some examples of what we're talking about here and what you're going to have to do. So here we have iron and sulfur, which are being combined. So again, a combination of iron and sulfur. As you can see, it's on the left side of the equation, we have on the left side of the equation, we have the reactants, and then on the right side, we have the product of iron sulfate. So what we need to do right here with this synthesis reaction is we need to look and see how many atoms of each element we have on both sides of the equation. So what we do is this. In the middle, we need to write down what elements we have. So we have iron, we have sulfur. And then we're going to kind of make a little chart like this. On this side, I'm going to write down how many atoms of the reactants I have. And over here on this side, I'm going to write down the number of atoms of the products I have. So I have 1 iron, I have 1 sulfur. Over here, I have 1 iron, and I have 8 sulfur. And now as you can see, the iron is fine, but my problem lies with the sulfur. And so there's a way I can balance that. Again, I cannot touch the subscripts, but I can do something with numbers called coefficients. Coefficients are numbers I can place at the front of the chemical formula. Now when I do that, what I'm doing is I'm changing everything in that compound. So here you can assume, even though it doesn't say it, that you have a coefficient of 1 and that you have a subscript of 1. Here you can imagine that you have a subscript of 1 and a subscript of 1. So really what you're thinking about is you're saying 1 times 1, and then right here 1 times 8. Over here 8 times 1, and right here 8 times 1. So you can see now my sulfur is balanced, my iron is not. So the way that I need to make this balance permanently is I can put an 8 right here. If I do that, then I have 8 iron and 8 sulfur. And I can erase all those little ones because those should not be there. So what I've done now with this equation is I have balanced it using coefficients. Again, those are numbers that you can place inside, to the left side. These are the large numbers in the chemical formula to balance it. Okay? So let's look again. Here's another example. This is going to be a decomposition reaction. Okay? And so for this one, I'm starting out with calcium chloride, and it is breaking down into potassium chloride, and it's breaking down to potassium and chlorine gas. So to set this up, what I need to do is I'm going to do the same thing, write my chemical symbols here, and then on both sides, I'm going to write down how many atoms of each. So I start out with 1 potassium, 1 chlorine, I have 2 chlorine right there, and then again, just imagine that's 1. So my problem is with my left side of the equation. I don't have enough chlorine. Okay? So what I need to do here is I'm going to place a 2 in front. Now that's going to change everything in that compound. So now, again, remember, you're going to imagine that you have 1s here. If it's not written down, imagine that you have a 1. Okay, so 2 times 1 is 2. 2 times 1 is 2. So now my chlorines are balanced. My potassium is not. So I need to have 2 potassium. I can change the coefficient here to a 2. And so now I have 2 potassium on the left, and I have 2 potassium on the right. And now this is balanced, and I'm erasing those 1s because it's not considered appropriate to have those in your chemical equation. So again, I have equal numbers on the left and right of the equation, and that is how I balance that. I'm going to kind of zoom in a little bit so that you can see what I've done there. Okay, so we're not talking about a complicated process. What you're trying to do here is just make sure that everything is the same on both sides. Okay, the third kind of chemical reaction that we want to talk about this year is what we call the single displacement reaction. And for this, we have iron and copper sulfate, and so we have copper and then iron sulfate. And so we want to set this up. Again, you're going to do it the same way. Alright, and then you want to make sure that you have the same number on both sides. You just want to count. So I have 1, it looks like 1. For copper I have 1 and 1. For sulfur I have 1 and 1. For oxygen I have 4. So imagine that you have a coefficient of 1 and you're multiplying that by the subscript. And again, remember that if you don't have a subscript, assume the number is 1. So here I have 4 oxygen, and here I have 4 oxygen. Okay? So this one is already balanced. I don't have to do anything to fix that at all. It's already good. There's no problems with it at all. Next, here is a double displacement reaction. So this reaction is, it looks very complicated, and you're going to see some of these. I mean, it looks like there's a lot going on, but let's just kind of break it down and see what's actually happening here. And by the way, let's go back to the single displacement. You can see what kind of happened there. The iron and the copper just basically switch places, and because the single results in 1 new chemical compound. Here we have the double displacement, and it's resulting in 2 new compounds. Basically, the sodium and the silver are switching places. So you get silver chloride, whereas before you had sodium chloride. But let's look at it and let's analyze it and see what we need to do. So we have silver, we have chlorine, we have sodium, we have nitrogen, we have oxygen. And we're going to go ahead and we're going to count those. when we do, we have 1 silver and 1 silver. We have 1 chlorine and 1 chlorine. Sodium, 1 and 1. Nitrogen, 1 and 1. Oxygen, 3. And then oxygen, 3. So when you look at this, it might look kind of complicated to you when you first examine it, but the truth is there was nothing we had to do there. It was already balanced for us. It was already perfect the way that it was. We did not have to do anything. But let's look at some examples where we do have to do something. I'm going to go ahead and erase this. Okay, so we have iron oxide, and it's breaking down into, actually let's skip that one. Let's go here to this. So we have lithium, and then we have hydrogen, phosphorus, and oxygen, and that's switching places. The lithium and the hydrogen are switching, so we have a single displacement reaction going on here. So to set this up, we're going to have lithium, hydrogen, phosphorus, and oxygen. And so what we're going to try to do here is we're going to try to make this balance on both sides. So draw your lines going across, and then let's count how many we have. Over here we have 1, over here we have 3. Over here we have 3 hydrogen. Over here we have 2 hydrogen. We have 1 phosphorus and 1 phosphorus. And then we have 4 oxygen and 4 oxygen. So our problem looks like it lies with both lithium and hydrogen. So take a moment, look at that, stop the video, and we're going to come back and see if you were able to come up with a solution for that.